Hello guys, you're welcome to IDC Learning Center YouTube channel with Mr. Mark Okafor. In our class today, we will be looking at differential calculus. To get started, we are going to look at limiting value of a function, or what you know as limit of a function. We are going to use some examples to break this down and for you to learn how it works. I want you to know that for limit of a function, x always tends towards 0. Now let's look at this function. Okay, so let's evaluate the limit of this function. If we have 7 minus 2x plus 5x squared minus 4x cubed. As x tends to 0, okay, you can replace this with 0. It simply means wherever you have x, replace it or substitute x with 0. So 7 minus 2, I have x here, I'll replace it with 0. Plus 5, I have x here, I'll replace it with 0. Then this square. Minus 4, I have x here, I'll replace it with 0. Okay, minus 2 times 0 is 0, plus 5 times 0 here is 0. Okay, 0 square is 0, that's 0 times 0. 0 cube is 0, minus 4 times 0 is 0. So I'm left with 7. My answer is 7. Easy, isn't it? Let's take question 2. Let's evaluate this limit. Okay, let's find the limit of this function as x tends to 0. You can see it here as x tends to 0. Again, we are going to substitute the value of x with 0. Since we have s squared here, it's going to give us 0 squared plus 5x will be 5, replace the x with 0, plus 9, divide by 2, replace the x with 0, square, minus 3, replace the x with 0, you have 0, plus 15. Okay, 5 times 0 is 0, so this is 0, this is 0, I'll be left with 9 in the numerator. This is 0 because 5 times 0 is 0. For the denominator, 2 times 0, this is 0, minus 3 times 0 is 0. In math, whatever you use to multiply 0, you get back 0. So I'll be left with this 15 for the denominator. At this point, I'm going to reduce what I have to the lowest end. To do that, I'm going to divide both sides by 3. 9 divided by 3 is 3. 15 divided by 3 is 5. So 3 over 5 will be my answer. Now, if you look at question 3, it's quite different from question 1 and 2. X tends to 5. Let's try something. If we plug in or substitute x with 5, what will it give us? We are going to have 5 squared, because that's replacing this x with 5, minus 25, divide by, now let's replace this x with 5. We have 5 minus 5. 5 squared is 25 here. 25 minus 25 will give me 0. 5 minus 0 is 0. So you can see that it will be undefined. So this is wrong. If you look at this numerator, this is difference of 2 squared. For those of you that might be hearing that for the first time, this is how difference of 2 squares work, in case you come across a problem like this. If you have a squared minus b squared equals, okay, so just pick both of them. It's the same as a plus b, close bracket, bracket, a minus b, close bracket. So this is difference of 2 squares. 2 squares here. But you might be wondering, here we have s squared minus 25. So this 25 is same thing as 5 raised to the power of 2, so it's a perfect square. Okay, so I can rewrite the numerator as s squared minus 5 raised to the power of 2 divided by x minus 5. Okay, so the numerator look like what we have here, isn't it? So we have, so this is difference of 2 squares, so this will give me bracket x, pick x and 5, x plus 5, bracket, x minus 5. Hope I'm not too fast. If you get confused anywhere, you can slow down, just take the video back, ensure you understand what I'm doing step by step. Okay, so I just followed this difference of 2 squares here, so this rule. So since I have this, so I'll pick x and 5, the same thing as s plus 5, x minus 5. Now you divide this by x minus 5. Okay, so here x minus 5, the denominator cancels x minus 5. I'll be left with x plus 5. From the question, it says as x tends to 5. Alright, so I can substitute this x with 5 now. So I'll have, replacing this x with 5 plus this other 5, my answer will be 10. Okay, for question 4, just like we did for question 3. For question 3, we have to break down what we have. Okay, we have to break down the function before we substituted the value of x, right? So by looking for the using difference of 2 squares. So have it at the back of your mind that whenever you are giving a function, if it's not in the simplest form, like what we have in question 1. Question 1 is in the simplest form, so we just have to impute the value of x. If it's not in the simplest form, you have to break it down. How do you break down? If it's not like difference of 2 squares like what I did here, then you need to pick the variable that has the highest power. Like for this function, this is the highest power, x raised to the power of 3. Use it and divide through. If I do that, so I won't work with s squared, neither will I work with x. X cubed has the highest power, so I'll divide through with s cubed. Take note of this. So you have 3x cubed divided by x cubed plus 2x squared divided by s cubed. I'm doing this because I said you must simplify your function before you substitute the value of x for limit. Okay, so plus x divided by the highest power, x cubed plus 1 over s cubed. Okay, now divide by the denominator, we have x cubed divided by x cubed plus 2x divided by x cubed plus 5 divided by s cubed. Okay, so s cubed cancels s cubed, so let me bring down 3 plus s squared. We remove s squared from here, I'll be left with x, so we'll have 2 over x plus x here 1, x here x squared, so I'll be left with 1 over x squared, then plus the last one, 1 over x cubed. Alright, now divide these by, sorry, let me clean that. Okay, s cubed here will give me 1, x here 1, x here 1, so I have 1 plus x here, we'll remove 1x from here, I'll be left with x raised to the power of 2, so 2 over x squared plus 5 over x cubed. Okay, is this clear? Now, at this point, we can now plug in the value of x. Alright, so you can see that I have to simplify first. To do that, I'll have 3, okay, plus 2 divide by, replace this x with 0, plus 1 divide by 0 square, plus 1 divide, replace this x with 0, 0 cube. Okay, so let's divide by, do the same for the denominator. 1 plus 2 over 0 square plus 5 over 0 cube. Whatever you divide by 0 is 0. So 2 divided by 0 is 0. 1 divided by 0 is 0. 1 divided by 0 is 0. The same thing goes for the denominator. So we'll be left with 3 over 1. That's this, which is same thing as 3. These are answer. Now, the danger, if you decide to plug in your 0 directly without breaking down first, your answer might be undefined. For example, if I replace this x with 0, this with 0, this with 0, this with 0, this with 0, okay? So we might get the wrong answer if we do that, okay? So that's why it's good to always break down what you have, the function you have, like I've done before, plugging in the value of x. Okay, I hope that is clear. Now we are going to look at continuity of a function. Now this question, before solving question on continuity of a function, I want you to know that there is a condition that must be met before you can say that a function is continuous. Here I said a function gx is said to be continuous at x equals to b. Look at the conditions that must be satisfied. If gs is defined at s equals to b, if the function exists, number one, okay, if the limit of the function exists. Now, if the limit of the function and the function are the same, equals to each other, then we can say that the function is continuous. I know this might be confusing the way I've explained it, so we are going to use an example to explain this further. Okay, so to do that, let's look at question 5. The question says, let's examine 4x, okay, g of x equals 4x cubed plus 3x squared plus 2x minus 1 for continuity at x equals to 2. So, since x equals to 2, g, when x, replace the x with 2 equals to 2, will give me 4, open bracket, replace this x with 2, we have 2 cubed plus 3, replace the x with 2, we have 2 squared plus 2, this 2, replace this x with 2 minus 1. Okay, so we have 4 times 2 cubed is 2 times 2 times 2 in 3 places, which will give me 8, plus 3 times 2 squared is 2 times 2, which will give me 4, plus 2 times 2 is 4 minus 1. 4 times 2 is 32, plus 12, okay, plus 4 times 4 minus 1 is 3. 32 plus 12, okay, what will it give us? 44 plus 3, which is 47. Now, if you go back to the continuity of function, the rule I said, the function must exist. So from what we've done now, you can see that the function is defined. Okay, that's 47. Now, if you want to check for the limit as well, okay, for what we have here, for, okay, hold on, let me clean this. Okay, the limit as x approaches to 4x cubed plus 3x squared plus 2x minus 1. Since this is like a simple function, a plain function, we don't need to break it down. Okay, so we are going to just substitute the value of x into, since x approaches 2, so we just substitute the value of x2 into the x here. We have 4 bracket 2 cube plus 3 bracket 2 square plus 2 bracket 2 minus 1. Okay, now this, what we have here, as it will give you what we had here. So if you simplify this, you are going to get 47 as well. So you can see that the function is defined and is equal to the limit. Now I can say that this function is continuous. All right, so that's how to solve for continuity of a function, and that's my answer. Okay, this will bring us to differentiation. When we talk about differentiation, I know what comes to your mind might be the process of finding the derivative of a function. If that is what you are thinking, then you are correct. Differentiation simply means the process of finding the derivative of a function. We usually use different notation for that, but I know most students are quite familiar with differentiating y in respect to x. All right, you are quite familiar with this notation. This is called the differential coefficient of y with respect to x. As we proceed, different meanings associated with dy dx will be unfolded, but for the time being, I want you to know that dy dx is either the gradient function of the curve y equals to f of x, or we can just say is the rate of change of y with respect to x. So dy dx, let's take this last one, is the rate of change of y with respect to x. We are going to look at differentiation from first principle. This is the formula you need to know. dy dx equals nx n minus 1. So I'm going to apply it here to differentiate this simple function, okay, so that you can understand how it works. So to do that, since I'm using dy dx, simply replace, there's a lot of proofs that I would have done to show you that f of x is the same thing as y, okay, but just learn it this way is fine. So I'm going to replace f of x, don't let it confuse you, with y. So let y equals x squared. Now let's find the rate of change of y in respect to x. So dy dx equals, now the rule, you use the exponent or the power to multiply the coefficient of what you have. This is x. The coefficient of x is 1. X is same thing as 1x, right? So, but just know that variables cannot stand alone. They always carry an invisible 1. So 1 is 1x. So if you have 2x, now the coefficient is 2. X is the variable. 10x, the coefficient is 10. X is the variable. Okay? So, now, since the power is 2 and there is an invisible 1, I said variable cannot stand on their own. So I'll use this 2 to multiply this one. 2 times 1 will give me 2. I have my x. Now, once you use the power to multiply the coefficient like I've done to get 2, you now subtract 1 away from it. That's what this is. So you have xn. If this is 1, s times n will give you nx, then minus 1. So n minus 1. So 2 times 1 is 2x minus 1. it will give me 2 minus 1 will give me 1. What will my answer be? Yeah, my answer will be 2x. Okay, so hope this is clear. 2x. Let's look at question 7. Now I've explained how to solve simple differentiation using the first principle. Let's try this. Y equals x cubed. So dy, let me bring it down here. The y, the x, the coefficient here will also be an invisible one. 3 times 1 will give you 3x. Subtract 1 from 3, you have 2. So this will be your answer, 3x squared. Okay, for question 8. Now this question is quite different from the other examples we've done. Find the derivative of y equals 1 over x. Now I want you to know that y equals 1 over x is same thing as x minus 1. I'm sure you can remember this from indices. So x minus 1 is same thing as 1 over x. Please don't forget this. This is same thing as this. Alright? So I don't want to go into indices. So I can just replace this with x minus 1. It's same thing. So if you have this, you can go back to this as well. And then if you have x raised to power minus 2, same thing as 1 over x, but then you have 2. I can now differentiate. Dy dx will give me, now the power now is minus 1. My coefficient, there's an invisible one here. Minus 1 times 1 will give me minus 1. Okay, x, I multiplied, subtract minus 1. Minus 1 minus 1 will give me minus 2. You can liken it this way. That I'm owing minus 1 and I borrowed another minus 1. How many will I be owing? I'm owing 1, I borrowed another 1, I'll be owing 2. Alright, so minus 1 times x minus 2. Minus 1 times x minus 2 is same thing as 1 over x raised to power 2. I explained it here. So my final answer, minus 1 times 1 will be minus 1 over x squared. Okay, I hope that is clear. If I'm too fast, you can gently rewind this video and just look at it again. Now we have more exercises from first principle. Okay, so we are going to just take some of them. So I would like you to try these questions, but also like to solve with you. Let's pick the first one. I'm going to be faster now. At least I'm sure you've gotten the idea. For the first one, y equals minus 2x cubed. Dy dx will give us 3 times minus 2, give us minus 6, right? That's the first thing to do. Okay, now subtract 1 from the power, that is all. 3 minus 2 will give you 2. Is it right? I have my answer. Okay, I'm going to clean the board so you can just look at what I've done. So I can take B. Now let's take B. Can solve with me. For B we have x 1 over 2. What do you think we need to do? Okay. Y equals 1 over 2 times invisible coefficient, which is 1. You have 1 over 2 x. Now 1 over 2 minus 1. Remember the rule. You use the power to multiply the coefficient, then you subtract 1 from it. So half 1 over 2 minus 1. What will it give you? The denominator is 2. 2 divided 2 is 1. 1 times 1 is 1. Minus 1 times 2 is 2. 2 times 1 is 2. 1 minus 2 will give me minus 1 over 2. Okay? So, the y, the x, if you differentiate now, will give us 1 over 2 x half minus 1 will give me minus 1 over 2. 1 over 2 times what we have here is same thing as 1 over x 1 over 2. Remember that again from indices. This minus means 1 over and x and this, alright? So now 1 times 1 is 1. 2 times x will give me 2x 1 over 2. Okay, again, if you find anything confusing, feel free to go back a bit. Now, whenever a number like or a variable, let's say 5 is raised to the power of half, it's the same thing as root 5. Okay, take note of this. So my final answer will be 1 over 2. Half here means root x. This will be my final answer. So just take note of that. So if you have, let's say 10 raised to power 1 over 2 is same thing as root 10. M raised to power 1 over 2 is same thing as root m. Okay, so don't let this part confuse you. X 1 over 2 is same thing as root x. Okay, I've gotten the answer for B. You can gently go back again, rewind the video, and probably make sure you understand everything I've done so far. Now we are going to take question C. I'm going to give you classwork. Alright, so I'm going to probably solve question C, and then okay, I can solve question C and D. Then I want you to solve E and F. You can drop your answers for me in the comment section. So for C, we have 1 over x cubed. Okay. This equals is same thing as saying x minus 3. I've explained that before. So whenever you have this, you can always convert to this. So an x minus 3 is same thing as 1 over x cubed. I can differentiate now. dy dx equals minus 3 times invisible coefficient of 1. Minus 3 times 1 will give me minus 3x. Now, minus 3, subtract 1 from it, minus 1. This will give me minus 3x. Minus 3 minus 1 will give me minus 4. Okay? That's all. We have our answer. Alright, we are going to take D now. We are going to also differentiate this. All these are under first principle. Feel free to ask any question. You can ask your question in the comment section. Drop a question. If you don't understand anything, feel free to also let me know. So for D, we have 3 root x squared. Now, you need to practice your indices because I'm using a lot of, we are coming across a lot of them here. If we reverse this, it's same thing as x raised to the power of 2 over 3, at least from your knowledge in indices. And if you have x raised to the power of 2 over 3, we can expand this to be x 1 over 3 times 2. So the 1 over 3 means cube root of x, which is this. Then this 2, look at it here. So this what we have here is same thing as this. So that's the first thing. You need to reverse the operation. So once you reverse the operation, you can now differentiate. So dy dx will give us invisible coefficient 1. 2 over 3 times 1 will give me 2 over 3. X now minus 1. 2 over 3 minus 1. All numbers have a denominator of 1. LCM of 3 and 1 is 3. 3 divided by 3 is 1. 1 times 2 is 2. Minus 1 into 3 is 3. 3 times minus 1 will give me minus 3. 2 minus 3 is minus 1 over 3. So I will have minus 1 over 3 here. Okay, this same thing as 2 over 3 times 1 over x 1 over 3. 2 times 1 is 2. 3 times x is 3. X 1 over 3 means cube root of x. So we have cube root of x. Is it clear? So my answer is 2 divided by 3 cube root of x. Alright, I hope everything we've done so far is clear. So I would like you to try E and also try F for me. Now we are going to look at differentiation rules. There are certain rules that makes differentiation easy and possible. Okay? So we have the rules of differentiation. What we have here is called the sum rule. I won't talk much about it because it involves your normal simple differentiation. So, but we'll just take some exercises on it. Look at these exercises. For A, we have 2x cubed minus 5x squared. We are going deeper now. Plus 2. Now, if I want you to find the derivative of what we have here, what will you do? Okay, let's differentiate this. There's something you should know. If you are differentiating constant, you always get 0. Okay, if you differentiate constant, you get 0. So dy over dx will give me 3 times 2, 6x. Now minus 1 from this, so it will be 6x squared. Look at what I did. 3 times this coefficient, which is 2, will give me 6. Remove 1 from the power. The power is 3. 3 minus 1 is 2. Minus 2 times 5 is 10. Remove minus 1 from the power. We are left with 6. This is a constant because there is no variable. Whenever you differentiate any number that does not have variable I mean x. If you differentiate any constant that does not have variable, what you get is 0. Okay? So, here we go. We have our answer, 6x squared minus 10x. I know it's getting easier. Okay, so let's take the B part. Now we have 3x squared plus 1 over x. I'm going to just give you a few minutes to look at this. Does it look easy or difficult? I'm sure you said easy. Let's start by rewriting this. So 3x squared plus, remember 1 over x is same thing as x minus 1. Okay, this same thing as this, so I'll replace it with this. X minus 1. So I can now differentiate. Dy dx will give me 2 times 3, 6x. Subtract 1 from 2. 2 minus 1 is 1. Okay? Plus minus 1 times, there's an invisible 1 here. Minus times plus is minus. Whenever the signs are not the same, is negative. Minus 1 times plus 1 will give me minus 1x. Now, minus 1 from the power. Minus 1 will give me minus 2. Is that clear? So my final answer will be 6x minus 1, expanding this will give you times 1 over s squared. You know, if you expand this, we get this. This means minus 1 over s squared. So this same thing as minus 1x squared. Bring it down here, minus 1 over s squared. Okay. Should I let you try C and D? Or probably let me take one of them. Which should I take? Okay, let me solve C. Then you can attempt this. Okay, let's take C. Okay, x cubed plus 2x squared plus 1 divided by x. Now, you know, I can also rewrite this. Or better still, I explained the importance of breaking down a function when we talked about limits. So I can use this x denominator to divide through. So I'll have x cubed divided by x, I'll be left with x squared. So I'm using this to divide through. 2s squared divided by x, I'll be left with 2x. 1s is gone, plus the last one is 1 divided by x. So s squared plus 2x, this plus 1 over 2 is 1 over x, is same thing as x minus 1. I've explained that before. This will be plus x minus 1. So let's differentiate this now. dy dx, invisible coefficient is 1. 2 times 1, I'll have 2x. Now minus 1 from this, remember 1, plus there's an invisible power of 1 too. Just know that x cannot stand on the same as x raised to the power of 1. 1 times 2 is 2x. Now minus 1. So this is raised to the power of 0. In mathematics, anything raised to the power of 0 is 1. So this is same thing as 1. 2 times 1 is 2. So 2 stands alone. Plus, okay, hold on, this won't be plus. Minus 1 times invisible coefficient is 1. Minus 1 times 1 will give me minus 1x. Minus 1 minus 1 will give me minus 2. I hope that is clear. So my final answer, dy dx, will be 2x plus 2 minus 1 over s squared. This is my final answer. Don't be confused how I got minus 1 over s squared. I got it from here. This same thing as minus 1 times x raised to the power minus 2 minus 1 times, this means 1 over s squared. Minus 1 times 1 is minus 1 over the x to here. Okay, so you can just take D. But the D, I want to give you clear so you don't get confused because of the square roots. Don't get confused. Okay, so whenever you have a function like this, the first thing, root x is same thing as x 1 over 2. Reverse the operation. Because I told you that 1 over 2 is same thing as root of that number. Okay? So now, plus 1 over root x is x 1 over 2 minus 3. I've made it easy for you, right? You can now differentiate, all right? So don't forget that what we have here, I can also rewrite this as x1 over 2 plus what? X minus half minus 1 over 2 minus 3. So differentiate this, okay? I'll let you complete this yourself. Okay, let's look at other rules of differentiation. Let's look at function of a function. These rules are very, very important so that we can be able to crack complex derivative like differentiation problems. Suppose we know that y is a function of u, and the u itself is also a function of x. How do we find the derivative of y with respect to u? Okay, this is called the chain rule, the formula we have. To solve questions like that, I'm going to give you some examples so that you understand how it works. We have to dy dx equals dy over du times du over dx. Okay, so let's look at other functions and know how or when to use this rule. So we'll be looking at exercises on function of a function. Let's start by looking at this A. If I ask you to differentiate y equals to 3x squared minus 2 bracket cube, this might likely be difficult for you, okay, because of this cube here. This is called function of a function, okay? This is called function of a function because we have, okay, do you understand better now? So the first thing you need to do is to let y, you know, y equals this, right? Now, let this be u. So if u equals 3s squared minus 2. Now, y will give us, if I use u to represent this, y will now give us u cubed, isn't it? So I have the value of u and I have the value of y. So let me start with y. Let's differentiate y in respect to u. dy du will give me invisible 1 because I said variables can stand alone. 3 times 1 will give me 3 u. Now 3 minus 1 will give me 2. Alright, I've differentiated y in respect to u, and that's what I have. I won't stop there. I'm going to differentiate u in respect to x now. Since u equals 3s squared minus 2, du dx will give me 2 times 3 is 6x. Now subtract 1 from here. So like 6x, which is something as 6 raised to the power of 1. If you differentiate a constant like minus 2, there's no variables, it will give me 0. I said that earlier. Now, once you do this, you can now go back and use the formula. This I'm using chain rule here. dy dx equals dy du times du dx. Okay? So this is a formula you use for function of function or question like this. So my answer will be dy du is 3u squared times du dx, which is 6x. So 6 times 3 will give me 18x, this x. Then what is u? The u is what? 3s squared. So open bracket, you have 3s squared minus 2. I just replace u with its value, then the square, which is 2, you write it here. So we have the answer. Okay, I've taught you chain rule. how to solve problems like this, but let's take another example on this. Okay, now the next example we are going to take is B. You can always go back a bit. For the B part, we have, hold on. Okay, for the B part, we have y equals to root bracket 1 minus 2s cubed close. Now, question like this might be confusing unless you use the rules of differentiation. So you always differentiate u in respect to x. So let u equals 1 minus 2x cubed. If I make u to be this, then y will give me root u. Okay, remember root u is same thing. If I reverse this, it's same thing as u 1 over 2. So I can say y equals u 1 over 2. So let's differentiate in respect to y. dy du will give me half times invisible 1. Half times 1 will give me 1 over 2 u, then minus 1, like always subtract 1 from that power. So 1 over 2 minus 1 will give me minus 1 over 2. I'll have 1 half u minus half. This will give me 1 over 2 root u. Now this means 1 over u half. u 1 over 2 is root u, sorry. Let's differentiate u. Du dx will give us, differentiate u in respect to x. Hope you understand how I got this. Half, this is this minus means 1 over u. This means 1 over u and half. U half is same thing as root u. These two, look at it here. So differentiating this, if you differentiate constant, you get 0. 3 times minus 2 will give me minus 6x. 3 minus 1 is 2. At this point, I've gotten dy du, which is this. Du dx, which is this. Okay, so let's use our chain rule. Using our chain rule, dy dx equals dy du times du dx. So I'll have dy du, which is 1 over 2 root u times du dx, which will give me minus 6x squared. Okay, so this is over 1. These 2 can cancel, go into minus 6, and I'll have minus 3. You can always rewind back a bit so you can be able to understand this better. Alright, so I have 1 times minus 3s squared will give me minus 3s squared over over root u. So dy dx equals minus 3s squared root. Remember, u stands for 1, this is u, 1 minus 2s cubed. So this is 1 minus 2s cubed. So this is our answer. Okay, I would like you to attempt question C and D yourself. Now let's look at the derivative of a product. What if it involves multiplication? So let's look at derivative of a product. Whenever you have